All right, what do you see here? This is a rectangular coordinate system. And we're going to look at the unit circle. It's a circle with a radius of 1 unit. Well, what does that mean? If we center it around the origin right there, here, see these points right here? That's what you have. There's the unit circle. I'm just drawing this. Oh, just pay attention. Okay, does everybody see that is the unit circle? And I'm going to blow it up in a minute. It's very small, right? But could you tell me what the radius is? It's 1. It's 1 unit. Could you name these points right here? What's this point right here? I'll make it bigger. So this ordered here is 1, 0. That is 1, 0. This is 0, 1, negative 1, 0, and 0, negative 1, correct? So if I were to draw a triangle inside of this circle, so in other words, if I were to cut this in half right here, everybody see what I did? From here to here. If this is 90 degrees, what angle am I talking about? A 45-degree angle. Can you guys see that little triangle?
Yeah.
I can't. So that's why I blew it up for you here on your notes. This is where we're at on the notes. I just wanted you to see in comparison to this little bitty circle right here. That's the unit circle. And I just blew it up. Okay, so in other words, this is 0, 1. This point right here is 1, 0. This is negative 1, 0. And this ordered pair is 0, negative 1. Are you guys with me?
Yes.
So now, that 1 unit, that 1 box that we were talking about, this is all happening in that one little box. I want you to understand the special triangles, the 45, 45, 90, and the 30, 60, 90. And this is where it comes from. You learn this in geometry. So if we took this angle right here, which is 90 degrees, and cut it in half, do you guys all agree that half of 90 is 45? Right? So if I drew a segment from here to a point on the line, on the circle, if this is 1 unit, you guys realize that that's also 1 unit, right? Your radius is 1. So now we have a 45, 45, obviously 90-degree triangle right here. Now I drew it down here for you. So I took this triangle out of the circle and I have it constructed here. We're going to play around with this for a minute. You learned in geometry that the sum of the angles of a triangle is what? 180. So if this is 90 and this is 45, obviously this has to be 45, right? And you also learned in geometry that if you have 2 sides that are the same, so if this is 45, 45, this is an isosceles triangle, and these 2 sides are exactly the same measurement, whatever they are. We're going to call it x. You also learned the Pythagorean theorem. What does the Pythagorean theorem say? So a squared plus b squared equals c squared. So in other words, tell me if you understand this. If we squared these legs, added them together, it's equal to the hypotenuse squared. Do you agree with that statement? Do you also agree that in algebra you learn that 1x squared plus 1x squared is 2x squared, right? And 1 squared is 1. You also learned in algebra how to solve this problem. You divided by 2, and you got x squared is equal to 1/2. And you also learned how to take the square root of both sides, and you came up with plus or minus 1 over root 2. Now, can you have common sense? Can you have a negative measurement of this triangle? No. So we automatically throw out the negative answer. So what you're saying here is if you have a 45, 45, 90-degree triangle with a hypotenuse of 1, this is going to be 1 over the square root of 2. And this has to be the same thing. So now, look at this picture right here. I don't like talking about 1 over root 2. So can I do something to this triangle? Keep it a 45, 45, 90. But I don't like the square root of 2 in the denominator. Can I get rid of that? I can multiply all 3 of these sides by the square root of 2. What's going to happen are those are going to cancel. So what you end up having now is 1, 1, and then this is the square root of 2. You need to memorize that triangle. You have to memorize it. So when we're referring to a 45, 45, 90 degree triangle, 45, 45, 90, remember the 2 legs that are the same measurement are 1s, and you multiply the hypotenuse by the square root of 2 times that leg. So now if I went outside of the unit circle, which this is actually outside of the unit circle, let's say I gave you a 45 triangle, and I said this was 10. Can you name the other sides? Well, this has to be 10 also. And you would multiply the hypotenuse by square root of 2 times that leg. Now, how do you go the other way? If I gave you the hypotenuse of something, let's say I said it's 5, and I said this is a 45. How do you go backwards? You divide by the square root of 2. And then obviously you can rationalize, multiply square root of 2, square root of 2. So it'd be 5 root 2 over 2. This would be 5, same thing. Or 5 root 2 over 2. So everyone have that memorized. 1, 1 root 2. 1, 1 root 2. Where did it come from? Exactly what I just did, right here. All right, now let's go back to our itty bitty circle here again. So another special triangle is a 30-degree angle. So if I took this and I did, instead of 90, I did 30 degrees, like that. Real small, not 45, but 30. So I have, here's my unit circle again. Whoops. But that's a 30-degree angle. Too small. So I just blew it up for you right here. So we have a 30-degree angle here, which means this is 60, and that's 90. The hypotenuse is 1. Well, let's go back to geometry. What did you learn? In geometry, you learned that the side opposite the 30 is half of the hypotenuse. So if we said the hypotenuse is 1, we know that the side opposite is half that measurement, so 1/2. How would we figure out what this side is? We're going to use the Pythagorean theorem. So it says x, if we square each of these legs, added them together, we get the hypotenuse squared. So this is going to be x squared plus 1/4 equals 1. Subtract a fourth. This is the proof of it. And then square root both sides. So x is going to be square root of 3 over 2. So this side is really square root of 3 over 2. And again, I don't like these fractions on this triangle. So if I took this triangle right here that I just said the 30, 60, 90, we called this 1, whoops, we called this a half, this is 1, and this worked out to be square root of 3 over 2. Those are too hard to memorize. How can I alter these sides? What could I multiply all 3 sides by so we don't have to deal with fractions? 2. So if I multiply this by 2, and this by 2, and this by 2, the triangle that you should memorize is 1, 2, square root of 3. Okay, so you should memorize this one. The 30, 60, 90. This is what you're going to remember. The shorter side is 1. You're going to double the hypotenuse. And this side is going to be the shorter side times the square root of 3. Do you remember doing this, you guys, in geometry? No? So you've got to memorize this triangle, because if I give you, let's say I give you a 30, 60, 90 degree triangle, and I say that this side is 10, the hypotenuse is 10, you got to know the relationship between these other sides. How do you get the shorter side? How do you go from the hypotenuse to the shorter side? Divide it by 2, so this would be 5. How do you go from the shorter side to the longer leg? You multiply it by square root of 3. So if I give you the shorter leg, you double to get the hypotenuse. If I give you the longer leg, you divide that by the square root of 3, and then you double that to get the hypotenuse. You got to know the relationship. Okay? Now, every triangle, because of the angle measure, every triangle will give you sides. If it's a right triangle, it's going to give you proportionate sides. So I could take, see that little unit circle that I did? Right there. I could take this circle right here, this little bitty circle, and I could make it, so here's my little circle. If I made the radius now, instead of a 1, if I made it a 6, so 6 this way, 6, 1, 2, 3, 4, 5, 6 this way, 6 this way, and 6 this way. And I drew this same circle. And now I took this and I went 45 degrees that way and drew my triangle. It doesn't matter if my triangle inside here, if the hypotenuse is 1 unit or if it's 6 units. The ratio of the sides will always be the same. So if it's a 45 degree angle inside here, it's going to be a 45 degree angle if I made it bigger. Its ratio of its sides are going to stay the same no matter what. Now there's 3 ratios that you probably remember. The sine ratio. The sine ratio, these are all ratios. They compare one side to another of this triangle. The sine ratio compares the side opposite to the hypotenuse. The hypotenuse is always the side opposite the right angle. Adjacent means next to that angle. Opposite is right clear across. So you guys should know what sine, cosine, and tangent means from 2 years ago. And we did this last year too. So what does sine mean? Sine is opposite over a hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. There are 3 reciprocal ratios. The reciprocal of sine is cosecant. Well, that just measures the hypotenuse over the side opposite. The secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. Do you guys remember this?
Yes.
Yeah, okay. Now, check out these. You gotta have these memorized. You gotta know these quickly. So, if I ask you what's the sine of a 45 degree angle, you immediately jump to this triangle right here, 45, 45, 90, which is 1, 1, root 2. So, sine of 45, sine means opposite over hypotenuse. So it'd be this 1 over root 2. And you're gonna rationalize it as root 2 over 2. Cosine is adjacent over hypotenuse. So again, 1 over root 2, or root 2 over 2, rationalized. And tangent is opposite over adjacent, 1 over 1, which is just 1. That's the ratio. So no matter what, how long your sides are, if it's a 45, it's going to have the same opposite to hypotenuse, adjacent to hypotenuse, and opposite to adjacent ratio. Now what are these 3 ratios? These are just reciprocal. They're just flipped. They're reciprocal. So cosecant is the reciprocal of sine. So you just flip that, root 2 over 1. And this is the same, root 2 over 1. And this is going to be 1 over 1. These are flipped. So if I ask you what's the sine of 30 degrees? So I'm gonna ask you to look at the 30, 60, 90, which is 1, 2, root 3. So sine of 30 means opposite over hypotenuse, so this would be a 1 to 2 ratio. Now if you want it, a lot of people will go from this one to the reciprocal one. What would cosecant of 30 be? 2 over 1. Cosine would be adjacent over hypotenuse, so root 3 over 2. And secant would be 2 over root 3. And rationalize it, which would be 2 root 3 over 3. And then tangent would be 1 over root 3, which is root 3 over 3. And cotangent would be root 3 over 1. Now looking at the sine, cosine, tangents of 60, now we're talking about this angle up here. So this now becomes the side opposite. So this is going to be root 3 over 1, or this is 1 over root 3. The cosine of 60 would be 1/2. Secant would be 2 over 1. And tangent would be opposite over adjacent, root 3 over 1. And then this would be 1 over root 3, or root 3 over 3. Hopefully this is coming back to you. So, this is like question 1 in your homework. If you are given a right triangle and one of the sides is missing, would everyone be able to apply the Pythagorean theorem to figure out any missing side? Because that happens quite often in this class. Is I might give you a right triangle and tell you 2 of the sides, 12 and 13, and you have to be able to figure out the side 5. So that's a given. So, example 2, it's just asking you, what are the ratios? It's a very easy question. It's asking you, given this triangle, you have to be able to locate the angle that they're talking about. So in reference to this angle, what would be the sine of this angle? It'd be 5/13. Cosine would be 12/13, and tangent would be 5/12. And you should be able to do all of the reciprocals. Now, what are these decimal numbers? That's just 5/13 is equivalent to 0.3846. So when you see a decimal answer, think of that's really just a fraction. And those are the decimal and fraction equivalents. Always reduce your fractions. Now, how do you do these questions on a calculator? And do you know, when it says, what's the cosine of 68? Do you know what that even means? If someone said, what's the cosine of 68? Do you know what you're doing? Okay. What that means is, if you, cosine of 68 degrees means, this says, hey, you have a 68-degree triangle, right triangle. So I'm going to say this is 68 degrees. Cosine means adjacent over hypotenuse. So for any 68-degree angle, whether it's this 68-degree angle, or it's this 68-degree angle, or it's this 68-degree angle, any 68-degree angle, its side adjacent over hypotenuse will be what ratio? Well, if you have the 83, what you do is you would just, first of all, make sure your calculator is in degree mode. Hit mode, and we set them last hour to degree mode. You should all be able to do that. On the Inspires, how do you change to degree mode? Let me tell you how to do that. Turn your calculator on. You're going to go to Settings, go to Home, the home screen. You're going to go to Settings, which is 5. And you're going to go to Document Settings, which is 2. And that should be in degree. The angle is in degree. And make sure you hit Make Default. Scroll down to Make Default and then hit OK. Okay, mine's already done. If you don't do that, I think the calculator toggles back and forth from degree to radian. So, all you do on this calculator, on the 83, if most of you guys have the 83s at home, so I'm going to teach you guys on both calculators. you're gonna hit just plain old cosine 68, and you get that answer. Now, how do you do it on the Inspire? Let me show you that, because you're gonna like to use this calculator. Go to home. Oops, after you hit. Okay. Go to calculate, and there's a button right here. It says trig. Hit that button, and look what you have. This is nicer than the 83s because it gives you all of them. The other calculators, the 83 does not have the other buttons. So did everyone get this? If you have an Inspire, and you're more than welcome to use this. So you're gonna hit cosine, go to cosine, and then hit 68, and then hit enter, and there you go, you get the same answer. Now, if you have the TI-30X, that cheapy one, you're gonna hit 68, then cosine on those. Everyone got that? All right, what do you hit for if it's an inverse one? Or a reciprocal one, I should say, not inverse. Well, on these calculators, you're gonna hit 1 divided by, we don't have a cotangent button. So you're gonna hit 1 over tangent and then 39. And you get 1.238. And then, but to do it on this calculator, you have a cotangent button, which is very nice. Hit cotangent and 39. And there's the same answer. So everybody see that? The difference. Sorry, that's bigger. So if you have the 83, you hit 1 over tangent 39. If you have the Inspire, you can just go ahead and hit the button. Now, what if you have the cheapy one? How do you do that one? The cheapy ones, the TI-30XA, you're gonna hit, for that, you might wanna write this down, 1 divided by, and then you're gonna hit 39 tangent. So for this next one, cosecant, you're gonna do 1 divided by sine of 25. But if you have the Inspire, I have to change my notes now. The Inspire, you would just hit cosecant 25. And then for the keystrokes for the cheapy 30XA, you're gonna do 1 divided by 25 and then hit sine. Okay? Questions? All right, question, go to the back. This is your homework. Nine and 10 are simply asking you for the 6 trig ratios. So you're just gonna make sure you rationalize the denominator. 15 through 20, you're gonna pick your calculator of choice and make sure you can do those. Those are on a calculator. 21 through 26, these are non-calculator problems. So I'm gonna do one with you. Look at question 21. It says, you want to know what the angle whose ratio, opposite over adjacent, is a 1 to 2 ratio. So I'm going to draw this triangle. You've got to figure out, you have to know what the angle is. So what angle would I be if my side, this is this, you got to know what the word sine means. Sine means opposite over hypotenuse. So we have a 1 to 2 ratio. What angle would this be? And that would be a 30-degree angle. So that's how you do these 6 questions. You're going to have to be able to do these without a calculator. Okay? And then the last 27 through 32, you're going to find the missing whatever they're asking you. So they want this one, tangent B. So they want to know, given this angle right here, tangent means side opposite, you have to know, you have to do B over A. Sine, if it says sine of A, here's A, it'd be opposite over hypotenuse. So you have to figure out, they give you some measurements, sometimes you have to use the Pythagorean theorem to find a missing side, but they just want the ratio. So today's all about getting familiar with those ratios, sine, cosine, tangent. 21, yes. Yes. Want me to re-explain it? Yes. Yes, so you have some unknown angle, theta, okay? So it says find the sine of some angle whose sine ratio, sine you gotta know is opposite over hypotenuse. So right away, you're gonna refer to these two triangles. And this is what I do right away. I do 1 root 2, and then I do my 30, 60, 90, and I do 1, 2, square root of 3. So is it a 45, is it a 30, or is it a 60? So it's this angle right here, because it's side opposite over hypotenuse, so it's a 30-degree angle. So if I said sine of theta is root 3 over 2, it's a 60, root 3 over 2. Does that make sense? If I gave you this question, this would be a 60-degree angle. Okay, because root 3 over 2 would be, that would be the 60. Side opposite of that angle. You get it? Okay, you're finding the angle whose ratio is that. So that's your homework.